Hi, everyone. Welcome to the Contributor Experience Project Community Call. My name is Nessa Pawson. I'm co-founder of the Contributor Experience Project and will serve as the host of today's event. And I would like to give a quick shout out to Melissa Mendonça, who is also in the audience. Melissa is a co-founder of this project as well. And Melissa, while I am doing my presentation, would you please let people in? And I'll make you co-host so you can do that. There you go. A few words about us. Contributor Experience Project is an open source community-driven project and community of practice dedicated to developing best practices for onboarding and supporting contributors to open source. Our goal is to provide a space to reflect, engage, and offer advancements in the work of effective transfer knowledge, contributor hospitality techniques, project leadership, and the communication infrastructure. The launch of this project was supported by the Chan Zuckerberg Initiative as part of the Essential Open Source Software for Science program. And to learn more about the project and how to join us, I will share some links in the chat. You can also connect with us on social media and check out our webpage. We have some resources for you if you are in this space actively practicing or curious about the topic. And now on to the topic of today's event. Technical documentation is an unsung hero of open source and open science. Without it, the hard-won knowledge and tools we create are lost to confusion. And in the setting of open source, many potential collaborators would be looking in. To me, technical documentation is a well-kept journal or a meticulous map on how to make a project better. And there are quite a few tools nowadays that can facilitate the work of the project, open source project leaders, to make this journey for new contributors easier. I would like to spotlight MyST Markdown, a powerful markup language, open source toolchain, and specification designed to create high quality web-based communications that are easy to publish, share, reference, aggregate, and build upon. And I couldn't think of a better person to present on this topic. Rowan Cockett is the author of MyST MD. Rowan, welcome. Thank you so much for making the time to talk to our audience about the project that you've been developing. Rowan, please take it away.
Awesome. Thank you so much. As Vanessa was saying, I'm Rowan Cockett. I'm in my day job. I'm the founder and CEO of Curvenote, where we create writing and publishing tools. And I just want to show a little bit of that to sort of start off sort of how we're thinking about these problems. And then throughout the presentation, I'm going to be sort of coming back from sort of more of a focus of open science communication into technical documentation and then starting some demos as well. And so some of what Curvenote works on is authoring tools for scientists. And so thinking about how to integrate metadata deeply and sort of directly into the ways that we're working so that if you're thinking about things like cross-references, you can actually reference a figure instead of just saying figure one, and you have direct references to that. And then also thinking about how we can integrate our technical software and data directly into these sort of writing tools. So on the left-hand side of the screen is a Jupyter lab, which you're probably quite familiar with here, and being able to copy links to interactive blocks of code out and directly paste those into what you see is what you get editors to sort of keep on going and have a more inclusive experience to authors who might not be familiar with these sort of technical tools like Jupyter. And one thing that we're quite interested in is the communication of this knowledge in sort of its like a very rich way with all of that metadata directly attached. And this is sort of thinking back to sort of framing scientific communication progress. And this is 350 years of progress in science, and the outcome of that. So on the left-hand side, this is the original paper about gravity, and on the right-hand side, this is a paper about the LIGO detector, which detected gravitational waves in 2017 and won the Nobel Prize then. And just a ton of work on the actual science, but in terms of how we actually communicate that science, the progress here is about 2 columns. And so that's something that is quite frustrating to me, especially when we're thinking about the types of data sets the scientists and our tools are collecting today. So this is an example of a zebrafish, which is 1.5 terabytes. And if you're trying to communicate this in, for example, a scientific paper, you're going to have to say, I need to zoom in here, and you show a cutout and you show an extra panel. But how we should be communicating is just having full access to the data so that we can actually just keep on zooming in and start to interrogate these ideas in a very integrated way. And I think this also has a lot of parallels to how scientific documentation is evolving in terms of bringing demonstrations directly into the documentation that we're doing. And so this is sort of where we think that science communication is going and technical documentation is going, is having these sort of very integrated ways of combining software, data, and the story, the narrative together, so that you have sort of an integrated experience between all of these different things. And so in 2021, funded in part by the Sloan Foundation, Curvenote open sourced many of our tools to help build and reinforce the MyST Markdown ecosystem. And so that was the tool that Inessa was talking about, which is MyST MD. And MyST is a markup language for structured text that can connect to data and computation and includes the specification behind the scenes of that sort of abstract syntax tree that actually builds these documents, as well as the tools and sort of diverse community that actually supports and contributes to these tools in the open source way. And so you can find more about MyST at mystmd.org. There's been about 14,000 books created with this markup language. Right now, it's about 13 to 15% of active Python documentation is using the MyST markup language. As of about 3 or 4 or 6 months ago, maybe now, it's part of Project Jupyter, which I think is quite exciting for the future of the language and making sure that that has stability over time. And there are many, many contributors to this over sort of the 5 or 6 years now that this project has been around. And so today I want to give a bit of an overview of what our mission is and sort of underlying the MyST project, and a bit of an overview of that tool and the markup language itself. And then I want to show a little bit more of some examples that we've done over this past year with reimagining the SciPy proceedings. And so every year the SciPy conference allows authors to submit articles as well as their presentations. And we've reimagined it this year with MyST Markdown. And then I'm going to go into some demo and questions and sort of freeform, just answering any questions that folks have on the call today. And so this is my sort of caricature of science communication today, which is this 2-column PDF of a data table on a side on your phone that you can't really read. And there's very limited integration to the data and the software. And I think in where we are today is we can actually start to reimagine this with some of these newer tools. And so what if in every single article that was written or technical documentation, you have access to actually interrogating data? And what if you can hover and click on any sort of footnote and just sort of dive deeper and see videos and presentations and just keep on going down that rabbit hole until you find the data and the demos and that sort of technical information? And what if we could press a button and spin up Jupyter resources and cloud resources behind the scenes so that we can actually interrogate and understand the models without with very limited effort. And this I think is sort of the ethos of science, is getting to that frictionless reproducibility where you can take something that somebody else has started and just dive in, get a new idea, and then start building upon that. And so that's sort of where we were thinking about taking the SciPy proceedings over 2024. And this is work that also is sponsored by my company called Curvenote. And so just sort of for a little bit of a snapshot of where the proceedings were in 2023. Is really an HTML only listing with sort of a PDF view of this. And so this is quite common for a lot of Diamond open access journals in the world. Is science is very focused on the PDF presentation and sort of having that paper metaphor be sort of ingrained throughout the way that we communicate. And so throughout the year, we've done a complete redesign of the scientific proceedings. And so you can see that this is an HTML web-first experience where you can sort of browse the entire paper. You can have links, as you do on any other website, to direct parts of that paper. Yeah, just keep on going in. It works on your phone. And then other sort of like features of this are being able to hover over various pieces, be able to actually see the figure references directly, things like abbreviations in context. And then for the GitHub, or for the SciPy proceedings specifically, and this is maybe a little bit outside most journal articles, but very much relevant to a lot of technical documentation, is you can have links to pull requests or GitHub issues where you have previews of those directly in line. And then like modern features like dark mode and copying code and all sorts of things, which are just really not possible in PDF really today. And then in 2024, there were all sorts of cool things that the sort of like when we start to liberate people from that PDF and paper thinking experience, just so much of the cool things that the scientific Python community is doing can be shown. And so this is an example that was live code directly embedded in those articles. And then, of course, at the end of the day, we can also have PDFs. And so we have sort of a single source publishing pipeline where you go from this MyST Markdown document and you can create those HTML first examples as well as PDFs as well. And I'll show a bit of a demo of doing that today as well. And so this was the workflow that folks went through when they were submitting their proceedings this year. So installing MyST Markdown, and that's what the demo today will be. And then they can write their draft. They can actually write that in MyST Markdown or in LaTeX directly. LaTeX doesn't have some of the computational functionality that MyST will have, but it does work for actually rendering the narrative content. And then committing on GitHub, if folks are familiar with the JOSS ecosystem, the Journal of Open Source Science, this is a very, very, very similar to that, is all of the collaboration and peer review is happening through the GitHub interface. And then there's some collaboration, and then eventually editorial acceptance, and then merging and deploying on the website. And that is a completely open review process. And so there are GitHub actions that are embedded in here. There's comments, as you're seeing here. And then there's previews where it has a little bit of extra information about sort of continuous checks that are run. And so these are things for metadata or editorial practices like the word count, or do you have an abstract installed? And so this is actually Alan's work, who's on the call today. And he did an amazing job of sort of integrating interactive figures directly into the work. That again is like a much more interactive way of presenting work that you can't do necessarily in PDFs. Awesome. Okay, so I want to talk about a little bit behind the scenes of how this all works. And so this is using a tool called MyST Markdown. And again, that's at mystmd.org. And that is really three things. There is the markup language, which is a language on top of Markdown. And then there's a specification, which both involves how that markup language looks, as well as how that's translated into sort of the underlying specification of data that's representing that narrative. And then there's quite a few open source tools that make this as easy as we can to get started and get things up and going. And so with MyST Markdown, if you have a folder of Markdown, which you might in technical documentation or Jupyter notebooks, you can go into that folder, and after you've pip installed mystmd, you can type 4 characters, MYST, hit enter, and sort of see what happens. And that will come and do its best job of creating a website for you as the base thing. And then this can also be used to export to many, many different types of PDF templates. And right now there's about 200 journal articles that we support, and we're working on better support for sort of book templates at the moment. And this is all possible by sort of that first translation into that specification. And so behind the scenes, what this does is it parses those Markdown, LaTeX, or Jupyter notebooks and brings that into a JSON spec that actually is machine readable and has all sorts of rich metadata and the content directly there. And so I want to give a little bit of a flavor of what MyST feels like and looks like to work with, and then we'll dive into some demos. And so MyST is, which again stands for markedly structured text, is built on as a superset of common Markdown. And so folks are probably quite familiar with Markdown text, a plain text flavor that has these sort of annotations directly in line, where you can define headers with the hash symbol, bold, italics, list, block quotes, and then increasingly math via LaTeX is also used. And then that is a relatively common form now, especially used on GitHub, and then that can be rendered into HTML or all sorts of other things. And so this is really helpful. Some of the things that aren't here are if you start to do more of these sort of scientific-like things, you'll start to add figure captions, and you'll have to say in figure 1 that's the caption, and there's no automatic numbering. And if folks are familiar with LaTeX or some of these other tools, none of that is there. And again, if you're referencing that directly in the markup, that's just a text-only reference, and it doesn't have any of these additional features that we were showing before. Awesome. And so MyST Markdown adds a couple extra syntaxes on top of this, and they are these directive fences. And so you have triple backticks or triple colons, and then open braces, and you can define what the directive name is. And so here we have a math directive and a figure directive. You can see that these have labels directly in them. And again, we can have math, and then that directive there has a label. A figure can also have a label, and then it also has a caption and potentially other options in it. And then because it's labeled, you can reference that directly in text. So instead of writing out figure 1, you actually say at, and then provide the label that you're referencing to. And that works exactly the same as citations as well. And so what that gets you, in addition to sort of the common markdown, is you can, again, hover over any of those references or citations, and then have sort of a much more interactive experience. And then we'll go a little bit more in the demonstration on how this works with Jupyter and tools like that. Fantastic. Okay, so I am going to enter a little bit more into a demonstration, and so do feel free to interrupt at any time, and as we go. And so it's not necessary to follow along, but I think it is relatively easy to get up and going. And so if you pip install mistmd and then type mist in a directory that has some markdown, then you'll get some sort of thing up and going. And then I've also created an article template that I'll be going through today to sort of look through that. And so that's maybe I can put that in the chat as well. The chat button is, oh my gosh, sorry. Oh, wow, that's an image. Okay, that's better. Fantastic. So we're gonna go through that, and I'll jump over to VS Code in a second. But just sort of to give an idea of what's in here, there's not a whole lot in here. There's a MyST file that has some configuration, mostly about authors and metadata. There's a couple of things that you'll recognize from Python, a data set, your environment configuration. You can use a number of different ways. Here I'm choosing to use the environment YAML. And then a couple images, and then two articles, or one article and one notebook for analysis. And if we look into the MyST YAML, this is the sort of configuration file. So this has things like an ID, a title, a subtitle, and then all sorts of authors, and then some other things like keywords and abbreviations if we want to do it. And then we'll sort of jump over to that in a second, but we're going to run MyST start and try that out. And so I'll just bring this up again. So again, the sort of four things that are helpful are this pip install mistmd. The documentation is at mistmd.org. We have a Discord, which is our real-time chat if folks want to join there as well. Fantastic. Okay, so this is the cloned environment. And so again, we have a couple things going on here. We have this MyST file, and again, that's the overall configuration for the project. And so this has things like title and subtitle and short title, and there's some more documentation about the different options that you can add here. And it has things like authors. And so this could be the author of your technical documentation project or your scientific paper. For scientific papers, it's quite common to have things like ORCID, which is an identifier for researchers. And then we can specify license codes directly in here. We can separate that out by content or code specifically. So for example, if our code is actually licensed to MIT and our documentation is licensed CC BY, that can be quite helpful. And then a couple extra things, some nice things on for adding banners, and we'll show that in a second, and then some exports. And so I'm going to go into the root of this directory, and I'm just going to type MyST. And then it welcomes you to the MyST CLI and asks you if you want to start the server right now. And I'm just going to hit enter. And if you're doing this for the first time, it will actually download the the article template for you and then start a local server. And so I'm going to go over here and I'm going to just sort of browse around some of the features of this. So we have things like dark mode, light modes. We have that sort of title block that, again, if I'm over in my title, I hit save, you can see that updates in real time, and we can actually edit things like the title and those sorts of things, and any of the authors, and again, the ORCID or the affiliations of those authors. And then a lot of the metadata is up here in terms of your license information and your projects. And then we get into the content of the article, and so this is an article template, so it's not a real article. A lot of it was created with ChatGPT, but it has things that are some pretty cool little features that are nice. So if we go over into the abstract here, and again, this is just a front matter block, similar to how a lot of other tools work, where you're having a YAML-based implementation of that. And then in here, all we have is a link to Wikipedia, and this has integrated ways to work with those links so that we can have integrated previews directly in there. And again, if that was a link to a GitHub issue, for example, or a GitHub PR, then that would also have a preview in it directly in there. Fantastic. So some of the next things to show are things like citations. And so this works with BibTeX if you would like. And so if folks are familiar with BibTeX, that sort of allows you to write an article about, or sorry, a entry about the thing that you were referencing that, for example, might have a note or a DOI, and then it gives you a key out here. And so if I'm over in the article and I'm starting to write, maybe right under this introduction, all I have to do is say @ and then that key, and that will give me a link directly to that citation. What I think is even cooler is if I have just, for example, some DOI out there that I want to reference, all I have to do is find the DOI and then actually paste it in to MyST Markdown. And then it goes out, figures out all of the reference information. You don't have to worry about like APA formatting or Chicago formatting or even downloading that BibTeX file. And it will bring in all of that information in a fully structured way. And then if I want to sort of like say in this article right here, I can start to add a little bit more of that syntax. And then it also creates that references section, again, right at the bottom of here. And we're seeing that that reference is pulled in dynamically and on the fly. And again, please interrupt if you do have questions, and I can just keep on going if folks are keeping up. Fantastic. Okay, so that's a little bit about references and citations. And things like footnotes, you might be familiar with. This is quite common in Pandoc Markdown flavor. And so that syntax is exactly the same there. And then some of those other pieces that are quite unique to MyST Markdown is being able to hover over a cross-reference and then see the figure directly. And again, that sort of allows nesting, in this case, to Wikipedia links. But if you have other citations directly in the thing that you're referencing, it can do those as well. And the way that this works is we have this figure directive that is the syntax that you use. And then the first argument of that is the actual source of the figure. And then you can label that and then reference it using this syntax. So here we can just paste that in, and if these two labels match, you can again have that figure reference anywhere directly where you're using it. Awesome. So in terms of tables, those also work quite well. This uses a couple different ways to do tables. You can have these either directly in sort of this GitHub pipe style table. There's also a list table view where you can just sort of list out your rows and columns in a bullet point list. And then you can also import tables from CSV data as well. Equations are quite similar, and so I'm not going to spend too much time on that. And then in this example, there's actually another file that I'm linking to here. And so this output is actually coming from a Jupyter notebook with an analysis in it. And so that Jupyter notebook looks like this. So we're doing some imports and doing some very lightweight analysis in this case to get to a matplotlib plot. And what we want to do is actually import this this plot and then put it directly in our article. And so what that sort of allows is encourages full reproducibility so that you're linking your code and data and then sort of importing them into your documents as you're going. And so that syntax specifically actually is just a comment at the top of a IPy notebook cell. And so this is this hash pipe syntax, and then you say label, and then you again give it a label. And then back in your article, all you have to do to import that is just do the hash and the label. And this hash just says that it's sort of a local local label that you're looking up. That can also be, again, an image as we saw before with the other figure, but that could potentially be importing from a different article as well. And so if somebody else publishes these with MyST Markdown, we can reach out to the internet, import that content directly into where we're going. And if folks are familiar with intersphinx, which sort of allows a similar concept of being able to pull in content or at least links from Python documentation, for example, you can actually pull in that content directly. And maybe if there's time at the end, we can think about that. Melissa's talking about intersphinx a little bit. And this is completely compatible with intersphinx. And yeah, maybe we can go into a demo of that in a second. Okay, so this is sort of a follow-up article that I'm like really proud of. I mean, in the sense that I created this morning with ChatGPT as my guide, and it was kind of interesting to sort of go through there and creating all of these different analyses and going backwards and forwards and getting to something that I actually want to share. And so that is also quite easy with MyST Markdown. And so I'm just going to use Control-C to stop that server. And I'm going to say MyST init -- GitHub pages. And I'm going to do that, and it's going to ask me a couple questions of which branch do you want to deploy from? What would you like to call the action? And then it creates a GitHub workflow file for me that I can look at if I'm curious, or I could just commit these files. So I'll commit this and give it a nice little icon, I don't know, and push those changes. And then if we go over to GitHub, Rowan C1, article templates, then we have an action that's kicked off. And and this is in the process of actually deploying the action. And so this is quite a fast action. So it takes about a second to install MyST Markdown and about 10 seconds to actually build the content, and then it will deploy the entire site. And so this is something that we've really focused a lot on, the speed and performance of MyST Markdown. And then we can again have that website that we can share out to the world. And this again has all of those features directly in it. So hover citations out to here. It has the Jupyter notebook that we're running in here as well. There are ways to integrate Jupyter directly into these pages to do those sort of examples that I was showing in a lot of the demos. I'm not going to go too much into that, but I can speak to that today if folks want. The the next piece that I'd like to show is how this works with Jupyter locally. And so I have activated the environment file locally, and generally, when you just say MyST start, it doesn't actually execute your content, and you have to tell it to execute. And so if I say MyST start dash dash execute, that will actually run all of the Jupyter notebooks in your project, and it will cache them efficiently, and then allow you to actually execute that content. And so I'll go over and open up that analysis document, and I'm gonna make a teensy tiny change to it's very large to this. So for example, if I just want to like change the label, you can sort of see what's happening in the background. If I refresh this, okay, there it goes. So okay, very small, but here's my label changing. I'm sure other folks on the call are doing slightly more exciting things. I don't know why my sidebar is there. So strange. There we go. So this is actually executing directly, and this is fast because it's actually caching all of those results. So if I'm making changes to the text versus versus the computational content, then it's going to be a little bit different. So this is a change that has not been cached. And so here I've actually started up that a Jupyter server in the background in the context of your environment. We've connected to it, actually built the page, and then we're off to the races here. And so all of those changes are sort of fully integrated and reproducible across your various projects. And so if you do have a lot of interdependent analyses that you're trying to bring together into a computational paper that you're sharing the results of, or for example, if you have even slightly interactive charts like Altair or Plotly or some of those types of static data viewers that work directly, those all work directly out of the box in MyST Markdown. Fantastic. So I think that's all I want to show. So maybe I'll leave it there, and then I obviously still have the have the demo up if folks want to ask any questions, and we can dive into some things like intersphinx or other types of references across documents. And so please, I encourage you to join the MySTMD Discord server if you'd like to chat or have some conversations. I'm at rowan.ca on Blue Sky, and you can give me an email as well. And so thank you very much.
Thank you, Rowan. I think we answered all the questions that were coming in through the chat. Or maybe one from Melissa. Melissa, feel free to use the audio to ask your question.
All right. So you mentioned JOS and talked a little bit about it. Do you have plans on about collaborating with them? Because I've been an editor for JOS, and the workflow is pretty similar to what you showed. People have their papers, and it's usually very simple. In that case, even simpler than what you showed. It's usually a two-page paper, mostly text. But it would be really nice to have people understand that process and what you showed with like having the automatic GitHub pages deployment and all of that. It sounds really interesting for that kind of work. So I was just wondering if you have talked to them.
I Arfon, who's the one of the founders at least of JOS, I met like the a couple days before I started Curvenote. He was an early advisor, and so I think it's no surprise that a lot of the functionality and sort of vision is very similar. And so we have talked a lot over the years. And I think having the SciPy proceedings be sort of the first incarnation of this way of building things is sort of one of the first steps to further integration back into the wider open journals community. So yeah, very, very, very interested in collaborating with folks.
Feel free to post your questions in the chat or use audio. We are a small group, so that is fine. Rowan, I have a question for you. It's related to generating and displaying rich outputs. Prior to starting this meeting, I mentioned that we have a project that we are going to use MyST for, and we'll make a big reveal a little later. Perusing the project documentation, I noticed that there's only a mention of Altair. It is a popular declarative visualization library and declarative statistical visualization library, and we could use Altair, but I'm curious if you have recommendations for other libraries, or maybe you've tried with some libraries and it didn't work so well. What should we steer clear from?
So a lot of the sort of popular statistical visualization libraries are supported, Altair included, Matplotlib, and Plotly, for example. I'm pretty sure that Bokeh works out of the box as well, and Data Shader, if folks are familiar with that. Generally, the goal of how we're working is to support the types of visualization tools that the Jupyter Lab ecosystem creates. We're using the same plugin extension libraries. It does get a little spotty when you're starting to take those extensions that work in Jupyter Lab and deploy them in other contexts. So if you're going off the sort of path that we've paved, open a bug and a report, and yeah, we're hoping that it should work. And so if you have one in mind, I'd be curious to know what it was.
We were considering Bokeh, so I'm glad you mentioned Bokeh. It's it's a project that we're doing with our interns, and Ulysses, who is on the call, is one of our interns. So we had this stack outlined, Bokeh, MySTMD, deployed via Netlify, and just wanted to confirm with you that this is the right direction.
Yes, yeah, it should work or be very close to working. I know at some point it has worked in the past, and I don't use Bokeh all that often, but I have seen examples.
Okay. Well, we'll keep you posted, and
yes, please open an issue if it doesn't work. Yeah.
I'll let you know how it goes. Well, let's see. Do we have more questions in the chat? A question
So
from
yeah,
Ulysses.
go ahead.
There's a question about a popular data visualization library from the JavaScript ecosystem, D3GS. Have you looked into integration with this library?
So we have definitely looked into integrations with that. So far, the plugins that we're thinking about are sort of focused on the Jupyter ecosystem. And so if you're wrapping up your D3 integration through a Jupyter widget, that we're trying to make support work for in terms of straight JavaScript plugins to the MyST framework. We haven't quite got that far yet, but that is something that we're working on over the next several months. And that microscopy example that I showed in terms of actually being able to zoom in was using some very custom JavaScript. And so as we open up that avenue, basically any JavaScript library will start to work. And that work is in sort of collaboration and using the framework of any widget, which is sort of a very up and coming popular widget framework that works across Jupyter compatible front ends. And so that's things like Colab or VS Code or those sorts of things. And MyST is aiming to be one of those compatible front ends for the any widget framework.
That's good to know. We have a question from Priyanka in the chat.
So is it possible to use this in our training materials? Is this the repository specifically that you're asking about? I think I licensed it CC BY, so do what you want and leave a reference back. Yeah, please use it.
Yeah, there's actually no license in the repo.
I will add that after.
So maybe that's, yeah.
Just
Suggestion.
focused on, you'll see that the Git history is about almost an hour old now, so I'll go back and fix some things up.
Well, we have a little more time remaining. If you have more questions, please don't hold back. Feel free to use audio. Use the chat if it's more comfortable, more convenient.
Maybe I can show one other thing that I think is like especially intriguing for technical documentation as well. One of the things that's quite common in science is actually instead of referencing an entire paper, you're referencing a figure of a paper. So, for example, you'd actually want to refer to figure 2 in this paper, and in with some syntax that we are thinking about, that actually is possible. And so here you can directly reference that figure. This is from a blog post or technical documentation that's going out to the internet, negotiating with that site, and then pulling that content in dynamically. And that works, of course, with equations, and it can also work with things like glossaries, which is, again, quite an interesting thing if you're doing some technical documentation and explaining concepts. Maybe you actually do need to sort of dive into that directly. And then it also works with interactive figures, which I think is just the coolest thing ever. Go ahead, Melissa.
Yeah, my question is if the target websites need to be using the same kind of technology, or is it just like any website?
It does require the target websites to be compatible with MyST. We are working on a Sphinx plugin that allows you to not change any of your documentation, but have some of these compatible outputs beside your site, which basically comes down to it needs a data file that you can reference that has this information. And so this is sort of thinking above and beyond what the Sphinx, the intersphinx outputs are, is providing a little bit more structured information. And so, yeah, I think that sort of vision for the technical Python documentation ecosystem, I'm very, very intrigued by, and seeing some early examples of how to stitch sites together, reuse content from tutorials or examples or reference documentation and pull that into like blog posts or new ways of sort of working. And so that sort of, yeah, it's treating it as an ecosystem rather than sort of a set of disparate sites that are deployed.
Do you have a repo for that Sphinx plugin that you can share?
Yes, I will write that down and share it after.
I can grab it in the Discord as well.
Yeah, yeah.
It looks like this is the end of the questions for today. Rowan, thank you so much for this presentation. Like, I personally super excited about using MySTMD in my project, and I'm also looking forward to see where you take MySTMD next. If you, to the audience, if you think of any questions, if there were some links that were in the chat and you didn't grab them, please reach out via Zulip or on social media. Thank you so much for being here, for joining us. I hope this was helpful. If you have ideas for future presentations, please let us know if you would like to present. That would be great. And let's continue this conversation on social media and in Zulip. Thank you so much.
Thank you. It was great to see everyone. Thanks for the question as well.